the cloud. Welcome everybody to this is the sprint demo for the Indy and libIndy projects at Hyperledger, and this is the Evernym team, I should say specifically. There are other teams working on these projects. Today we've completed the 18.14 sprint, the 14th sprint this year, and we've got a packed agenda. We are working hard on improving ledger stability. We recently released, did a round of releases. The 1.3 release, sorry, 1.4 release for the node, and we're working on 1.5. It contains a number of stability fixes, as well as we changed the log levels of various messages to try and improve performance there. So that release is expected to go out soon. On the SDK side, we have been focused on the payments API. We got some feedback that the payments API was not generic enough. We want to make sure that the API is useful for a variety of payment processes that anybody who uses Indy can write their own plugin. And so we've been making that more generic. We've also been working on improving the way the wallet export format is serialized, that we have the format we like going forward. We can take it out experimental. And the third change we made to the wallet, the SDK, is to add filtering to the anoncred workflow so that it's easy to search large wallets for specific credentials. So that was the main goals there. This is going to roll into the 1.6 release of the SDK that we wanted to get out this week, but we decided instead to postpone till next week to this coming sprint in order to complete the work on the payments API. So with that, let's dive into the demos for today. Nikita's volunteered to talk about the loads and stress testing that has been completed as we're improving the stability of the ledger. Then Sergey is going to show one of the availability concerns we had with the ledger is that if you create too many open connections, there's no way for the ledger to clear those out and resume availability. So Sergey is going to show how we are addressing that. Similarly on the SDK, we need to make sure the open connections are closed. So Sergey M is going to show how we do that on the SDK. And then we're going to have Artem demo the searching for large wallets that is important there. So I will stop sharing my screen. And Nikita, you're welcome to share your screen.
Hello.
We can hear you, yes.
Okay, I hope you see my screen.
We do not see your screen yet, but sometimes it takes a minute.
Oh, we can see it.
Oh, yes, I can see it now.
Okay. This is a document where we place all our results. I take a link into chat. We make load testing every day. Sometimes it's 24/7 process. This allows us to collect information about our readiness for TDE. It's also the path to reveal some errors that arise from a sequence of rare events, for example, not disconnecting out of memory and some other critical but unusual events during workload. At the moment, our best performance results are 10 writing transactions per second and 74 reading transactions per second when workload generated by 1,000 simultaneous clients. This workload had been generated for 3 hours. Another our best results that we writing transactions for 12 hours with speed about 15 transactions per second from other thousands of clients. It's good enough for our stability, but not enough for our TDE requirements. We also need to make some improvements in our scripts to provide another types of transactions. For example, it's a revocation and payment transactions. We still working on them. Also, such regular activity allows us to monitor performance changes between versions as well as resource consumption under load. We have some statistics that collected during load test from each nodes that helps us to understand how many memory and disk space and other resources involved in the node work. Also, we try to conduct DDoS attack to pull from 10,000 clients, but we haven't enough data to reveal some results for other. And we will continue to engage in load testing in following sprint. Any questions?
You mentioned that there is one area where we're not hitting our performance target, but I didn't understand which area that was. Can you repeat that?
If you open one of our issues who contains acceptance criteria for our load test, we achieve 1,000 of clients. We achieve this throughput criteria, but we haven't we didn't use all of these types. We use
yes, and this is because we cannot yet. Well, we just have, I think, the first the packages for payment for tokens just this week, so we haven't yet tested how it works with payment ledgers. Yeah, and for revocation, it's also the testing is in progress.
So it's not that we're out of compliance; it's that our environment doesn't allow us to exercise that part of the system yet.
Yeah, because it's kind of a dependency on this.
Yeah, that makes sense. Good to know.
Any other questions?
So just to summarize, we achieve the load and acceptance criteria. So the pool can write for 3 hours with 10 writes per second and 100, almost 100 hits per second without any issues. And if you write more than for 3 hours, then it's possible to write up to 1 million transactions. Yeah, so it's like a most.
Yeah, it's great to see. And I also want to point out that we had to write the scripts to inject this load into the network, and that was part of the effort that is recently undergone. So it's great for us to be able to build that confidence that the system's holding up under us throwing all this load at it. So thank you very much, Nikita.
Thank you.
So Sergey Shilov can share your screen.
Yeah. Hi, everybody. Can you see my screen?
Yes.
Yeah. Okay, so let's start. My demo is about open connections issue. we solved this problem by line stack restart, and well, I'm going to show you a system test which we implemented before. Sorry. Oh, thank you. We implemented this test before our implementation, so we followed test-driven development fully. And let me show the test. Firstly, I'm going to show this, first of all, this for Windows that you can see. It's these are consoles corresponding to each node of the pool. Pool consists of 4 nodes in my example. And first of all, let me check pool configuration. You can see these parameters that tells that firstly stack restart is disabled, and we expect that our system test will fail with such settings. Start each node of pool and then go to client console. First of all, let me tell a bit about SDK. SDK have connection timeout to pool about 50 seconds. When this timeout is spent, then a client process finishes with pool ledger timeout error if client has not been connected. So in our test, each client is running separate process. Number of clients we can specify in by this parameter -c. Oh, I forgot. I have a setting of IP tables on each node, which restrict more than 100 connections. So we expect that we will have about 100 clients connected, maybe a little bit more. I will say about it a bit later. So let's start the test. Now clients are trying to connect. Now we see that currently 100 clients are connected. At this time, other clients trying to connect to the pool.
While we wait for your timeout, is the default behavior in 1.5 to have is having this disabled like you're testing now, the default behavior in 1.5, or does 1.5 have it enabled so the fixed behavior is showing?
This is disabled by default in 1.5, yeah. And in 1.6, yeah, in approximately 2 weeks in August it will be enabled.
So now other clients were cancelled by pool ledger timeout, as we can see, we have finally 100 clients connected, 15 clients not connected. So let's stop. Sorry for this backtrace. It's due to inter-process communication. And now I'm going to modify Indy Node config to enable our new feature with client stack restart. As you can see, max connected clients num is 100. I reduced restart timeout from default. Well, what was default? About 180 seconds. I reduced it to 15 seconds in scope of this test. So let me save it. Okay. And now I'm going to restart each node. So let's start our test again. Now we're waiting for connecting clients.
And so that restart timeout means that when you hit the maximum number of connections, after that amount of time, it's going to clear the queue and reset all the connections. Is that correct?
Yeah, yeah. Now each 15 seconds, client stack is restarted. So that each 15 seconds, new clients have a chance to connect.
Very good. And so the client is responsible for dealing with their sessions getting terminated, which is what the next demo from Sergey Minaev is going to show us how the SDK is improved in dealing with that termination.
Just a short comment about why we do it on the server side as well. If all applications use libindy, then the problem should not be reproduced because libindy will terminate client connections. But if some malicious entity will create a custom script to still keep don't close connection on the client side, then we need to have this fix on the node, as Sergey presented.
Yep.
Yes, so we can see that our test passed. We have 150 clients connected. So that's it. And just one word. Don't forget that this is that was the client's race. Yeah. So we don't give one person probability of all connected clients, all 150. Yeah, it's all up to clients to win this race. Yeah, up to zero accurate race. So with high probability, we have 100. No, all clients connected. That now we can see.
Very good. Thank you very much. Let's move on to the next.
Any question? Any questions?
I appreciate the explanation. We're gonna questions can be people can submit questions later. We've got to move on to the next demo. So.
Okay. Thank you.
But you answered all my questions. I butted in, so that was good. Thanks. Sergey Minaev?
Thank you.
Sorry,
Thank you,
Minaev.
Richard. Let me share my screen. Hi, everybody. On the SDK side, we also had some logic to resolve problem with open connections. On my screen, you can see design documentation that is placed into Indy SDK repo docs design folder. Here you can find some details about how we resolve this. In previous version of SDK, connection may be closed only by application side. It's too difficult to our application, and if application will not close connection, it will be opened forever while application is running, even if there is no activity at all. It's major reason why we notice our problem with open connection. And in new version of Indy SDK, we will manage a network connection automatically without any activity from application side. The connection will be opened only by demand. Moreover, if SDK is processing requests with state proof, only one connection to only one node is opened, not all connections to all nodes as in previous version. And after some period of inactivity, all connections will be closed. There is also a limit to number of requests by single connection. This limit allows to avoid situation when applications send requests one by one with some small interval, and it may result in forever connection. But as we have a limit to requests per connection, this issue isn't actual now. These changes are already present in master branch. Appropriate PR is merged. And in the future 1.6 release, this functionality will be added to stable. So I hope in the next week, all application based on new Indy SDK will not take connection forever. There is also a positive side effect. During these changes, we improve our test coverage. I have improved that because we don't just increase test coverage, but we move significant amount of tests to unit level. So this allows us to make TDD process for SDK project more clear. That's it. Thank you.
That's really useful. Both the Sergey Minaev and Sergey Shilov, both of those efforts to defend the network against too many connections is one of the key criteria we had for the network being robust in production. So it's great to have that work done.
Thank you very much.
Excellent. So our last demo today is Artem showing us the wallet filtering. We can see your screen.
Okay, hello. I would like to tell about changes that we have done in anoncreds API. The main idea of these changes is integration of tag-based search into anoncreds functions. In anoncreds API, there are two functions intended for getting a list of credentials. First one is prove or get credentials, and second one is prove and get credential for proof request. To achieve this goal, first of all, we have updated prove restore credential function. Now this function stores a set of tags. This set you can see here. These tags allow us filtering credential by schema parts and also credential definition parts. And also there are two additional tags for every attribute in credential. First one is used for checking existence of any attribute, and second one used for checking value of any attribute. Next, as I mentioned before, in the stable version there are two APIs for filtering. We have updated the behavior to support tag-based search, but we kept the signature without any changes. So we saved backward compatibility with latest stable version. Also, now these methods work same way, that they can be filtered in two different formats. First one is as it was in the stable version, strict filter, written here, and also these methods can accept wallet query language, any query build it according to wallet query language. Also, I would like to notice that we have marked these methods as deprecated, and these two. because they immediately return all fetched credentials and load them in memory. We have added two chain types APIs to avoid this fetching, which APIs allow us fetch credential by batch. First one is pull resource credentials is equivalent of pull or get credentials. This method returns as a search handle. This search handle can be used later in this method. This method can be called multiple times. And last, we have to call close method, which makes this search handle is invalid. Also, there is equivalent method for search credential for specific proof requests. I would like to notice that both of these methods accept only queries in VQL format. Also, I would like to notice that this method has an additional param extra query instead of old one. By using this param, we can pass any additional query for any requested attribute or predicate. For example, if some restriction is absent in proof request and I know exactly value of some attribute which credential which I would like to use, I can pass extra query and same way reduce the count of credentials that which will be returned. Also, we have added new API method that allows us getting only one credential by specific credential ID. We have kept all tests related to getting credentials and getting credentials for quick request. Also, we extended test coverage for these methods to accept queries in VQL format. Also, we wrote a set of tests to coverage new API calls like search credential for request and search credential. That's it. Thank you.
That was excellent. I know people have been anxiously awaiting that functionality, so thank you for showing that. And it'll be interesting to get feedback. So that's the demo for today. Here's the link to the load and stress testing results that Nikita put into the Zoom chat, so people can find that. The next sprint, the SDK team is going to finish up the payments API and get the 1.6 release out. And then we also had a number of bugs that we want to make sure get into that release. So we're going to work on that. And 1.7, and then we're going to start the 1.7 release. We've finished the functionality we're anxious to have for moving the network from provisional to interim availability. That benchmark in network availability we're really keen for, because some people are going to start using it for production, but it's not broadly adopted yet. So interim availability is the benchmark we're looking for with the sovereign network, and we believe the SDK is there. And so 1.7 we're going to start looking at fixing some technical debt and refining what's already there and making sure our bug count gets really low, and start planning for long-term improvements. And feedback from the broader Indy community is going to be helpful there. On the ledger side, on Indy Node, we're going to the next round is sorry, my brain just paused as I was looking at the wrong board and getting confused. The next sprint, we're going to continue work on getting to interim availability. So additional stability fixes, improving the way the log messages are reported, and improving performance are our main goals there. Specifically, we're improving the way catch-up completes, view change completes, so that it's more reliable. That's our goal. as we move towards the 1.6 release on Node that is the one we want to use for interim availability. With that, we're going to close because we're over time. I guess we have 30 seconds for Nathan, Adam, or Tyler, our off the team visitors, to asking questions. Adam, do you have any questions?
No, looks great. Thanks, you guys.
Appreciate you attending the team demo, and we'll get this posted somewhere and share with other people. So thank you very much for your preparation, team.
Thank you.
Bye.